I hope everyone's having a great evening. I am Mr. Ish. Thank you for joining me. In this video, I'm showing you in an easy manner how you do Lewis structures for those 5 compounds that you see over there. And notice everything is nitrogen based because it works well in terms of teaching you how to do Lewis structures. Your best tip is always count the number of valence electrons that you have. Remember, if you have 2 items, the bond in between right here represents 2 electrons. If you have an item with regards to 2 bonds, that's basically 4 electrons. Each line represents 2 electrons. If you have 2 bonds, that's 2 times 2. If you have 3 bonds, you know it'll be 2 times 3 or 6 electrons. At any point you have a compound, let's just call that compound X, and you have a plus over here, you'll do the total valence electrons, you minus 1 from there because of that positive charge. It means there's less electron, there's a deficiency of electron. Anytime you have a positive in terms of that, you minus 1. If you have a plus 2, you would minus 2. At any time you have a compound with like a negative charge, you will add 1 electron to your total count. If you have a compound with, let's say, 3 electrons extra, then you'd add 3 electrons. These are the items you need to keep in your mind when you're doing your Lewis structures. The single most important tip for you is count your valence electrons. We're doing the first compound, NH3 ammonia. You know, nitrogen always has a valence of 5, hydrogen always has a valence of 1, but there are 3 of them. So you'll have 5 plus 3, you should have 8 valence electrons once you've drawn this out properly. Start with nitrogen, it always looks something like this. You have 5, and hydrogen always looks like this. And you know you have 3 of those hydrogens. If you combine these up, you know you can form a bond over here, you can form a bond with these 2 and here. When you do this, you'll basically have something which looks like this, and everything should count. There should be 8 valence electrons, and that structure will be good. You have 1, 2, 3, 4, 5, 6, 7, 8. Remember, each bond here represents 2. You have 2 times 3, 6, 7, 8, 8 electrons, and this structure here is good. Remember, normally nitrogen likes to have 2 lone pairs of electrons. That's just the nature of nitrogen, and you keep that in mind when you're doing your Lewis structures. So NH3 is done. Let's look at NH4+, which is the ammonium cation. The ammonium ion is not hard to do. You have to count your valence. You have 5 from here, you'll have 4, 1 from each hydrogen, then you have to minus 1 because this represents a minus 1. You should have 8 valence electrons when you're done. Remember that positive charge represents an electron deficiency, not an electron excess, but an electron deficiency, hence you minus. You start with this nitrogen, it looks like this, hydrogen looks like that, there are 4 of these, and then I'll put 1 over here. When you combine all of these, you know here you're getting a bond here, here you're getting a bond, here you're getting a bond, here you're getting a bond, and what happens, you have this extra electron. We'll worry about that at the end, but what will your compound look like, and I'll show you exactly what it will. You have that, that, and that, and then you gotta put that plus. Now let's look at this electron right here. You see this little extra electron? Well, we're supposed to have 8 electrons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Here I have 9. You see this extra electron? We want to account for it. It will vanish because we're supposed to do a minus 1. This electron here vanished away because we're not supposed to be having it. We have a polyatomic ion here which is electron deficient by 1. Hence this structure is good. You'll have 1, 2, 3, 4, 5, 6, 7, 8, 8 valence electrons, and you're good. Remember, here we were having this extra electron simply because we were looking at nitrogen as 5. This would have been a case where nitrogen was ideally having a 4. 4 plus these 4, you're giving your 8, and you're good. This right here is a peculiarity you have to keep in mind. Let's look at this. Nitrogen oxide or nitrogen monoxide, this right here will give you 5. It's a neutral compound, just like that. There's no positive, there's no negative, so whatever you have in terms of valence is exactly what you should have. Oxygen is 6, you should have 11 valence electrons. Nitrogen, you know, is something like that. Oxygen is something like this. Now what can you do over here? What you can do is you can take this electron right here and push it right over here. So you're looking at something like this. You can take these 2 electrons and bring them right here, and they'll get involved in this bond. So now you're looking at something like that. You're supposed to have 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're good so far. You can take these 2 electrons and push them right here and make a double bond. What you'll end up seeing is something like this. Right there, and that right there would be your final structure. And I'll make it big over here for you. It looks something like this. you should have 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 valence electrons, and we're good. And this structure is good. You could have done this in any way you want. Just remember, you can form extra bonds simply to help you account for the electrons or use them up in the procedure, but in the end you should still have the total number of valence electrons, which we do 11 here and 11 here. So this compound over here is done. Let's look at the next one, and you know you have to do nitrite, NO2 minus nitrite. Do your valence count. You know you're getting 5 from here, you're getting 6 times 2, and then here you're having a plus 1 because it's a negative. There's an electron excess. 5 plus 12 plus 1, you have 18 valence electrons. How do you go about drawing this? Well, let's look at it. Nitrogen will give you exactly something which looks like this. You can even draw it out like that. Oxygen, you know, will be this. But let's do your count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Add in your extra electron. And now what do you have? Bring this over here, bring this over here, and let's see what you can do in terms of a bond. You can create that. These 2 electrons can just come down over here, 2 over here, these 2 can come down, and then you have everything as it's coming through. Now look, you have basically 1, 2, 3, 4, 5, 6 electrons around oxygen. You have the octet around nitrogen, the octet around oxygen. If you were to bring this over here, you can help solve the deficiency here we have in terms of octet rule, and it would work. And look what would happen. You'd have this, and everything would have an octet. You'd have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 around nitrogen, and then 8 around oxygen. But you would have to do your electron count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and it's good. This structure here is good, but it's a resonance structure. You can write another one like this, where you flip the double bond around to the other side, and it would look just like that, and that's your other resonance structure. Both of these structures in terms of energy are equivalent. They just look different in terms of appearance. Double bond here, but they're resonance structures. And look, we have to do here an extra addition because we have an electron excess. We counted our electrons, and we had to make sure in this situation we were ending up with not an octet around the oxygen. 1, 2, 3, 4, 5, 6. It was 6, but by moving these 2 electrons of nitrogen we make an 8, and it became 8 around this, and everything has worked out. So that's the nitrite. Nitrite looks like this. It has 2 resonance structures. And the last one, nitrate, do your count. You'll have 5 from here. You'll have 3 times 6 valence electrons from oxygen plus 1. What is this? 18 plus 5 plus 1, it's 24 valence electrons. That's what you should have. Nitrogen will be 5, oxygen will be 6, each of the oxygens will be 6, as you can see. But we're supposed to have 1 extra. I'm going to bring it right over here, because now I'll have 24. I'll take these 2 electrons and form a bond over here. You see these 2 electrons right here? I'm going to push this over here, and I'll form a bond over here. I'll take these 2 from oxygen and push them here and form a bond. What do I get? I'll have nitrogen here with those 2. I'll have oxygen, and here I'll have oxygen. Look, everything is working out except for a deficiency. I should still have 24 electrons, and I will. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 8 around here, the octet rule, 8 around here, 8 here, but I have 6 over here. How can I fix this 6? These 2 can come down over here and form a double bond, and that's exactly what will happen. This is how it's going to play out. I'm going to remove this arrow, but this is exactly how it has to play out now. Nitrogen does not have the extra 2 electrons which it likes to have, but it doesn't in this case because it had to lend them and complete the octet around oxygen. And this right here would be your structure. It would be a resonance structure of 3 resonance structures because there are 3 different forms, but everything there would work. You have 24 electrons, you have octet rule around everything, and you can have resonance structures. Your other resonance structure would be like this, and you can see it. It would be exactly like I'm showing you. Here's one resonance structure, here's the other, and the last one, and we will draw it for you right over here. You can bring nitrogen double bond downwards. That's your 3 resonance structures, and everything looks good with the nitrate. Just see how the electrons moved around to form the bonds, how we had a deficiency here in terms of 6, but by pushing those here we converted into 8 and we're good. Everything here has an octet rule completed, just like you would have seen in these previous compounds. But that right there is how you do Lewis structures. Thank you for watching.